Probability distribution. There are two possible approaches in statistics. One is experimental approach, in which we actually perform experiment, and the other is theoretical approach, in which we make probability distribution table and get the required results. I give you an example to understand both approaches. Suppose I have to find the mean score or average score in case a fair dice is thrown once. Note that a fair dice has 6 faces, and the scores are 1, 2, 3, 4, 5, 6. And since it's a fair dice, so each side has equal chance of appearing. Now, if suppose I'm looking for average by experimental method, then what I do, I will throw the dice n times. N could be anything, like n could be 20, 200 or so on. So throw the dice n times and add all the n results. And your average is sum of scores divided by n. This is experimental approach because you are actually doing the experiment. In theoretical approach, there is no need to do the experiment, and for that theoretical approach, I have to make probability distribution table. And before making probability distribution table, consider the following facts. A fair dice has 6 faces or 6 sides, and numbers 1, 2, 3, 4, 5, 6 are there as scores, possible scores. And since it's a fair dice, it is unbiased, so each phase has equal chance of appearing. I can say probability of getting 1 is equals to probability of getting 2 is equals to probability of getting 3 is equals to probability of getting 4 is equals to probability of getting 5 is equals to probability of getting 6. All have equal chances, and the chance or probability is 1 over 6. In this situation, the random variable, which is a discrete random variable, is capital X, and this X is taking values 1, 2, 3, 4, 5, 6. I can make probability distribution table and note the following, that in probability distribution table we take probability, while in experimental approach we take frequency. That's the main difference. So in probability distribution table, one row or one column is for possible values of random variable X, and the other row is for probability. And as I pointed out earlier, each phase has equal chance of appearing, so probability is 1 over 6 in every case. In order to find the mean score, I will use this formula. You have to note this formula, it's very important. All x, you have to consider all x must be multiplied by the probability, and you get the sum. This sign is for sum. So what I do, I multiply all my x values with probability and add. So you can see I'm multiplying all x values by the probability and adding all the results. So if I simplify it, the answer is 3.5, which is my mean score in case of a fair dice. You can see there is no change, like in experimental approach you get different result. If you're throwing it 20 times or if you're throwing it 200 times, you get different answers. But since probability is fixed, so in theoretical approach, the probability distribution table will give me one answer only. So in this case, in case of my example, my answer is 3.5. The average score is 3.5. You can also find variance by using this probability distribution table. The formula for variance is ex square minus ex whole square. Remember, ex stands for mean. There is no difference. Mean is expected value of x. So for variance, I have to find expected value of x square minus expected value of x whole square. In order to find expected value of x square, I will multiply each x square by the probability and add my results. So you go back here and note that I'm simply putting square on all x. So 1 square multiplied by property of 1 and likewise. So this is how I get expected value of x square, which I simplify. I'll get 91 over 6. Now I can plug my values in this formula. Ex squared is 91 over 6 and ex I already have 3.5. If I square it, I get my final answer on simplification as 2.9166. In examination, you have to write your answer to 3 significant figures, so this is your answer. I can give you one example. Mrs. Rupel chooses 3 animals at random. From 5 dogs and 2 cats, the random variable x is the number of cats chosen. Draw up the probability distribution table for random variable x. Now in this question, your x is number of cats chosen. And there are 5 dogs altogether, there are 2 cats altogether. This gives you total 7 animals. But you have to choose only 3. You have to draw the probability distribution table for x. So first you have to decide what are the possible values of x. This random variable x can take 0, 1, 2. Since you have 2 cats maximum, so either there will be no cat, 0 cat, 1 cat or 2 cats. But you have to choose 3 animals. Now let me find out the probability of x equals to 0. If there is no cat, then there will be all 3 animals are dogs. And probability of getting dog is 5 over 7. Since there are 5 dogs, 7 is your total. So probability of getting dog is 5 over 7. So 3 dog will be 5 over 7 times 4 times 6 plus 3 over 5. Since it is without replacement, be careful. If it is not specified, then you will consider such trial as without replacement. And getting first dog is 5 over 7. But when you go for the second dog, 1 is less. There will be 4 dogs and the total is also 6. And the next dog will be 3. 4 minus 1, 3. And 6 minus 1, 5. So if you simplify it, you get 2 over 7 as the probability of having 0 cat. Now you can work out x equals to 1, which means there is 1 cat, and it's quite clear there are 2 dogs and 1 cat. But there is a permutation possible. Permutation means you can take cat, dog, and dog like this. So you have to have knowledge of permutation. So since there are 3 spaces, so I've written 3 factorial and 2 are repeated, 2 dogs are repeated, so I divided by 2 factorial. So this is the permutation possible in this situation. Now you will write the probability. Probability of getting first dog is 5 over 7. There are altogether 5 dogs and the total is 7. So first dog is 5 over 7. The second dog is 1 less 4 over, total is also 1 less 4 over 6. There are 2 cats, so the probability of getting cat is 2 over 5. And you multiply it by the permutation of this whole arrangement, and your final answer is 4 over 7. Then you go for x equals to 2. There are 2 cats, so 1 dog and 2 cats. Again, permutation, there are 3 spaces, 1, 2, 3, so 3 factorial, and 2 cats are repeated, so it's divided by 2 factorial. Probability of getting first dog is 5 over 7. The second animal is cat. There are 2 cats, so 2 over 6. And then 1 cat is left, 1 over 5. Multiply by the permutation. So probability of getting x equals to 2 is 1 over 7. Now you can construct a probability distribution table in which your x take value is 0, 1, 2, and the probability is 2 over 7, 4 over 7, and 1 over 7. Another part of this question is, you are given that expected value of x is 6 over 7. Find the value of variance of x. So expected value of x is already given to you. Variance of x, if you recall, the same formula, ex squared minus ex whole square. And ex squared is x squared multiplied by the probability of x. So 0 squared into 2 over 7 plus 1 squared into 4 over 7 plus 2 squared into 1 over 7. If you simplify it, you get 8 over 7. And if you plug the values in the formula, you will get 20 over 49 as your answer.